So in this video we'll be covering the software of a robot fleet system. So essentially there's basically three parts to it, actually essentially four. Well, there's first of all there is the Arduino code or the microcontroller code, then there's the server code, and then there is the user interface. Now why I say there might be four is because we're first building a test or prototype user interface, and then we'll connect it to a more advanced user interface. But essentially, so it's three components that you need, and then you do need the database as well. Okay, you can omit the database depending on your application, but in our case, in most cases, you probably do want a database as well, and we'll be using a SQL, MS SQL database for this. Okay, so we'll be looking at Arduino code here. Okay, so the first thing to note is what libraries are we using. So you will see that okay, first of all we need wire. It's just used due to us using serial communication, and it's just good practice. And there's a story behind it, but yeah, wire is included. We don't directly use it, we just internally require it. Then ADX, this is the ADX L345, this is the accelerometer library. Then the ITG is the ITG is the gyroscope module. So, and then HMC 5883L is our compass module, and it actually uses, and this is just part of a compass module. Okay, and then for the GPS, we're using Tiny GPS as our GPS system or library. And then we're using software serial. Now software serial in this case, because we're using Arduino Uno, it caused a little bit of problems. Usually you'd want to use hardware serial wherever possible, but the Arduino Uno only has one hardware serial port. So now if you use, now in our case we've got two places where we need to use software serial. So, and you'll see that there's some interference between the two, so it's a delicate dance. You know, if we didn't have this in here, if we could just use hardware serial, things would be a lot simpler. But I guess this is just one of the limitations of what we're working with. So okay, if we scroll down in the code, I'll just give a quick overview. You're welcome to pause your video, and I'll probably upload this code as well. So essentially we've just got a section where we're storing the gyroscope information, and then we've got a section where we're controlling the motor. So we're just defining the motor pins essentially here, and we've got a section for the to store the compass details, the compass heading essentially. And then next up we've got our GPS itself and the connection that it will be using. So then, okay, the next important part is, okay, we need to define an APN because we're working through the GSM network, so we use the APN. I'm just using JustWorks SIM cards, and the APN is JustWorks, and then the URL that we want to connect to. So in our case, the important part is, okay, I've got a server which I'll get to later, which is called droptime.co.za, and on there we've got a page called sim800.aspx, C#.net ASPX page, and then we've got parameters. Now these are currently hard coded in here. The ID of a device is test, and the password for this device is 1234, and then we've got DT equals and just empty. Now this is supposed to be data, right? So anything after this would be data. So now therefore, so obviously the data would be things like the current heading of a compass, the GPS location, and so forth. So we need to add that to this array of bytes. So therefore I've got a buffer which will store that. So we'll use this as our base URL, and then just append our the password and details to the back of that. So that's essentially the basis. There are multiple ways that you could do it. You could have uploaded a file in raw bytes instead of using the query string or the URL. You could have used HTML headers to attach each section. So there are various ways. This is just the quickest way. Not the most safe, because obviously this information will be exposed to your, to all the middlemen in between, all the routers and so forth, So, you don't want to leave open password text like that, and you don't want to put it on a YouTube video either. So, okay, then next up, we've got we've got the setup part of the code, which is fairly simple. Okay, so all of this, from my side, I'll just go through each library and essentially copy and paste from the example code that they give. We just reuse the example code as far as possible. When I know there's no errors, and I'm catering for everything. So the example code, here we're just setting the motors, and we're just turning them all off. With the accelerometer, we're telling it to power on. The gyroscope, we're initializing it, and this is quite an important value. I'm not sure exactly what that does. I believe it's just a version control type thing. Then you've got the compass to begin, and then just to determine which type of compass it is, there's some settings that we'd want to change depending on whether it's HMC or QMC. So, and then for the accelerometer, we just essentially need to tell it what we're going to look for and what information we're interested in. So we're not interested in tap detection and so forth. I actually need to change some of these things. But we're interested in X activity, Y, and Z. Those are important parts. So that's our initial software. Okay, there's a lot of information on the internet about this, on this library itself, on the accelerometers library. Okay, then next up we've got our second serial port. As you'll note at the above, we've got serial ss.begin, not the most intuitive name, but ss.begin at a baud rate of this is 9600. Here we've got serial.begin, and I like that it should maybe have been SS2 if I really wanted to keep to the cryptic standard, but yeah. So any case, so here we've got a serial 2, and it's connected at a lower baud rate. The lower the baud rate, the better it is. Okay, this is for, to explain, this is for the SIM800 communication over the GSM network. Now, for it to be able to process high speed, or let's say process information reliably, you want this baud rate to be as low as possible. Therefore the information is sent, well, essentially slower, and it doesn't need to rely on rapid processing to ensure all the information is correct. But the problem is, if you set this to too slow, then it means every time you want to communicate with a SIM800 device, it takes quite a while. Every character is literally, if you half this, you wait double as long for it to communicate, and there's quite a lot of back and forth communication. So in terms of time and so forth, what causes a big delay is essentially the fact that we're running at 4800 baud rate. This does work at 960 as well, but I've just found it more reliable at a baud rate of 4800. You can also obviously go for 2400, but then I found it's just too slow. It's just everything just it just takes ages. So that's a SIM800. So next up, okay, so when we're just initializing it, setting a power mode to normal. You can set it to minimal or normal. We're just setting. In a setup module, this is just essentially setting up a SIM800 module. We'll scroll that down to that code. This is it essentially over here. So a setup module just says, look here, is the SIM800 ready? get the signal. If a signal is greater than just wait until the signal is greater than 0, and then connect to a network, set the APN, and then it's ready to essentially connect to the internet. So that's a setup of it. So it's fairly straightforward, nothing weird and strange about that. Okay, in the main loop, we essentially just have this bit of code in here, right? So what we're doing is we're doing this our logic is divided into 2 phases essentially. I'll rewrite this code, but this is just to show, or at least for a prototype. So what we'll do is initially, okay, this all comes down to, you'll see here, first of all, let me maybe just point this out. You'll see here we're doing a serial is listening. If it isn't listening, then we'll say, okay, serial listen. And below, we'll also do a SS is listening. If it isn't listening, then set it to listen. This is how you switch between different ports, or different software serial ports essentially. It's not possible to communicate out of both of them at the same time. They do interfere with each other. So therefore that's why this looks all weird and so forth. So, but essentially we just have it in 2 phases. So we'll say we've got a check time where every so many counts. It starts off with 100, and then we've got it up to 10,000. We'll lower this, but this is just every 10,000 time that it's run through a loop, it will do the sim 800 logic, and this will essentially communicate with the internet. And just before it does that, it would also just do a quick update on the compass to see which way it is looking. And while it is not doing any of this, it will continue to update the GPS. Now a GPS that continuously needs to get information from a satellite for it to be able to pinpoint its location. So you want this to be running as much as possible. And yeah, so it's quite important that this is always running. Now we can look at those individual functions, but like I said, to do at the GPS port, we're literally just getting information, seeing if there's information on the serial port, noting that there is information received, and then we're reading it, displaying it, and passing it to the GPS encoder, part of an encode function of a library. So after that, if we have a valid location, we're just displaying it to the serial string, and that's it. That's also what this display info does. It's just this part where we're doing the location is this, the time that we received, the number of satellites, etc. But that's not important. What's just important is the fact that we have received information. We're not storing it anywhere. We can access it at any time through this function. So then the next important, do motors, that was just the test, drive motors, we'll get to that in a bit. So next important part is to do compass. So we're just reading the compass values, reading the gyroscope, getting putting it in vector format, doing some calculations to determine the roll, pitch and yaw, and then essentially we're reading the compass itself as well. Okay, we're setting out a declination angle, reading the compass, and correcting it according to a function. So because look here, essentially, if you take a compass module and you look, let's say you look east, and dead on east, and if you point the compass downwards, it will essentially tell you that the compass is reading a value as if it's more north. So but then by looking at the gyroscope, we can see that the module, the whole tank is tilted. Therefore, we just need to compensate for the tilt, and then we can deduct that from the angle, or add it to the angle that we use, that our compass module is receiving. So that's the important part over there. And then we've got the sim 800, where we've got when we're connecting, where every time we'll try to connect to the server to see if we can connect, if it's not marked as connected already. There are some reasons why you'd want to go with this approach, because some IP addresses just are not you put it this way, you've got problems with them when you try to connect to networks and so. So what will happen here is this system, or the code will run, it will connect to the internet, it will get an IP address, it will try to connect to the server. If it fails, it will disconnect, and it will keep a connection, and if next time, if it fails, it will disconnect and restart the connection. If it doesn't fail but it doesn't get valid information, so it gets a HTTP error, then essentially it will also restart, disconnect itself and restart itself. So so sometimes we'll stay on the same IP for, let's say, 10, 20 or 100 calls to the server, and if there's any problems, it will reset, it would get a new IP address, and it would connect to the server. Let's say it might fail on the first time, then it would reset, connect, get a new IP address, connect to the server. So that's the logic that's just going on over here. And while we're doing that, we're also sending the GPS location and coordinates, essentially GPS, a latitude, longitude, and a compass heading. We're attaching that to our URL. So now we're using a string class to do this, and then we're just converting that to a buffer, a byte buffer, and then calling the function, and if taking that command that we received, sending it to our function called send command to robot. Now this can just currently take a few commands. It can turn either left, you can give it turn left. Now this is where some accuracies and so forth. So with this left, it's still, this is not optimal, but essentially it will turn the motor to say, turn the motors on to turn left, wait 150 milliseconds, and then turn it off. So your accuracy, your set, read this way. You might be able to, you might overshoot or undershoot the intended direction that you want to reach by having a fixed value here. But for test purposes, it's sufficient. So same with turn left, turn right, we've got drive forward, and this accepts 2 additional parameters, the speed of the motors and the duration that it needs to run. And then we've got a turn to angle. Now this uses the compass, and it will turn the motor to an angle, or we can say turn to a GPS location, and essentially turn the motor. This I haven't completely implemented. This would be kind of a next step that we'll be busy with. And that's a core of the code. It's not, in terms of Arduino code, there's nothing additional really to it. So it definitely needs to be neatened up, and a lot of these commented lines of code, this is from testing and so forth. And so important thing to note is you need to be careful if you're with a software serial. If you're using that with hardware serial, they might interfere with each other as well. So if you've got strings that you're sending, you need to use the macro function and try to use that macro function so that you can send a string, and so it's stored in RAM or in flash memory instead of RAM. That's just something. If you don't do that, if you've got too many strings, you'll get interference. So, but in any case, that's for Arduino code. Fairly simple, and the core of the code, really the core absolute logic, comes down to this bit of function, this send command to robot. This is where it reacts, and this is what we need to refine from here. So all of the rest of stuff, sure, we might want to make it look pretty, but this is the core of the code and the logic and what we can do with a robot. Okay, so on the server side, there is essentially 3 pages that we need. Okay, you can write this in any language that you want. Okay, I'm sticking to ASP, just making things a little bit simpler. So essentially there's three things that you need. You need a way to send commands to the robot, or rather, let me put it this way. You need a database where you can store information. So our robot will need a page or interface to communicate with a website, which will then either get and or store information in a database, and we need another page or somehow for the user who wants to send information to the robot to be able to access or to essentially save data to the database. So it all comes down to the database, really. Okay, then we've got some basic logic, obviously, that we need to implement. So first of all, starting at the database, okay, I'm reusing, or I'll explain this project a little bit later, but it's a project called Drop Time, but I'm reusing some of just the basis of it. So essentially the database, all of these tables are irrelevant. It's just what's important is the robot command table that I created. So this is just for testing as well. This is just so that we can send commands directly to our robot. So first of all, we've got our table. I'll open it up in our definition view. So essentially we've got our ID, which is just for primary key, the device ID, which we might link to our GPS device over here, so they can work together. So we can, just for later in project. When a test command that you want to send, this is the same as sending through a serial port. It's now just sending to the database, and when the robot reads it, it will read this command. The password, well, this is basically the device password. The data received, so this will include all the GPS, longitude, latitude, and compass direction, and the last update date, just so that I can see when last this information sent. Sure, there's a lot of additional things you can add to this, but for testing purposes, this is kind of a core that we need for it. We need a way to send data. We need a place for us to send data and a place for us to receive data. So then, so that's the database side of it. So then, let's say, okay, from a user, I'll go to the easy part. From a user interface, we just need in this case, just a simple website. That's just a robot, the details. I've got simple text boxes, and along with your button. So I've got a button that says send command. So depending on what I've entered in the current command, it will put write the data to the database. So I can say retrieve data, and it will retrieve all the data from the database, including the current command. So I can see what it is trying to do. So that's the user interface, user page. And okay, in this case it's just called robottester.aspx, and then we've got the sim 800 page. Now the HTML for that is pretty much empty. We've just got a literal there, and what we're going to do is we're going to write directly to the output. So essentially we're trying to store the information, such as exactly that, the longitude, latitude, everything that we can detect from the data. And we're using a query string to get the information out. So we're using lon for the longitude, lat for latitude, ID, password, DT, and as you can see, this is where the DT from the Arduino code comes in. So essentially, and then we're just taking that data and writing it to the database and saving our changes. That's kind of it. Okay, and what we're returning, what's important is we're returning the last command, or the test command to send is being placed in this variable called return, and we're actually returning that as the literal. And it's as simple as that. So our robot will now, our Arduino code will now get what information is stored in this string over here, which might say now turn left, turn right, turn to an angle, so that's a core of the server side of the code. Okay, and then finally okay, what will be done in the next phase would be to integrate this with a fleet management software package. So we'll take this package that we're busy developing, and we'll utilize this to control the robot. So currently we can control our basic vehicles and trackers and so forth. You know, your normal tracking type of functionality. But we want to essentially say this is no longer actually just a vehicle that's being tracked, but this vehicle over here is one of our robots, and it needs to receive a command so that it follows this exact route to the destination and stays at the correct position. So I'm not sure what's going to happen here if this is accurate, but we'll connect it up and we'll see what happens. In terms of the code for this, I'll cover that in a separate video altogether, as this is quite a package on its own. You're welcome to directly just use Google's API and get the tracking information and build your own dashboard and so here we've just built a fancy dashboard, or we have one already, and we're just going to repurpose it.